Problem 1. The density of granite is given as 171 pound per feet cubed. Convert this density to gram per centimeter cube. Solution. Given conversation, 1 pound equal 453.6 gram. 1 feet equal 200 2,830 16.850 centimeter cube. To find the density in gram per centimeter cube, we first convert 1.1 pound slash feet cube to gram per centimeter cube. And you can follow this way. At the last, you can see the answer C equal 2.774. Problem 2. If A is acceleration, V is the velocity, X is the distance, and T is the time, what should be the units of A and B respectively if the equation A equal V squared over T plus V over X is dimensionally correct? Solution. For the equation to be dimensionally correct, the units on both sides must be balanced. From the equation, A must have units of velocity multiplied by acceleration, so A has a unit of meter per second square. B must have units such that when multiplied by x, it gives units of velocity squared divided by time, so B must have units of meter cube per second. Answer C, meter per second square, meter cube per second. Problem 3. Which of the following is not true about acceleration? Solution. The correct answer is C. Acceleration is directly always in the same direction as velocity. This statement is not always true. Acceleration can be in the same direction, opposite direction, or perpendicular to the velocity depending on the situation. Answer C. Acceleration is directed always in the same direction as the velocity. Problem 4. Which of the following is not true about freely falling objects? Solution. The correct answer is D. The acceleration of freely falling object at the top point of its path is 0. At the top point of its path, the velocity of the freely falling object becomes 0, but acceleration to the gravity is still acting downward. Answer D. The acceleration of the freely falling object at the top point of its path is 0. Problem 5. Stone is dropped from location 60 meters above ground, assuming no air resistance. What is the height of the stone above ground at the moment when it is moving at the speed of 29 meters per second? Solutions. Use the kinematic equation V squared equal V naught squared plus 2AS. Given U equal 0, initial velocity at is dropped from rest. V equal 29 meters per second. A acceleration equal 9.8 meters per second squared acceleration to the gravity. S is required. Plug the values in the solution. 29 squared equals 0 plus 2 multiple by 9.8 multiple by S. Solve for S. S equal 29 squared over 2 multiple by 9.8. S equal nearly 42.9 meters. Answer is 20. Problem 1. The density of Problem 6. A ball is thrown from the ground vertically upward. The ball reached maximum height of 85.8 meters above the ground, neglecting air resistance. What was the initial speed with which the ball was thrown? A 41 meter per second, B 32 meter per second, C 24 meter per second, D 12 meter per second. Solution. When projectile reaches the maximum height, its final velocity becomes zero, assuming no air resistance. We can use the kinematic equation final velocity square equal initial velocity square plus 2 acceleration multiplied by distance, where Vf is the final velocity, which is 0 meter per second, the maximum height. Vi is the initial velocity. What are trying to find? A is the acceleration to gravity approximately 9.8 meter per second square downward. D is the displacement, the maximum height, which is 85.8 meter. Problem 6. A ball is thrown from the ground vertically upward. The ball reaches maximum height of 85.8 meter. Plug in the known values. 0 equal V initial square plus 2 point minus 9.8 meter per second square multiplied by 85.8 meter. Solve for Vi of the initial velocity square equal minus 2 point minus 9.8 meter per second square multiplied by 85.8 meter. V square initial equal 2.9.8 meter square multiplied by 85.8. V initial square equal 1683.12 meter per second square. Taking the square root both sides. V initial equal square root for 1683.12 meter per second. V initial nearly equal 41 meter per second. So the correct answer is A, 41 meter per second. Which of the following is true concerning the 5 vectors shown in the graph? A plus B equals C, B, A plus B plus D plus E equal 0, C plus D plus E equal 0, D, all of the above. Solution. Let's analyze each statement. A plus B equals C. This statement suggests that the vector sum of vector A and B equal vector C. Looking at the graph, it seems like the true and the tail of vector C is connected to the head of vector A plus B. Thus, option A is a choice. B, A plus B plus D plus E equals 0. This statement implies that the sum of vector A, B, D, and E equal the 0 vector. By observing the graph, it is evident that vector A, B, D, and E from closed loop starting and ending at the same point. Therefore, their sum would indeed be 0, so option B appears to be correct. C. C plus D plus E equals 0. This statement suggests that the sum of vectors C, D, and E equal the 0 vector. The graph of vectors D and E seem to be cancelled out the vector C, resulting in a net displacement as 0. Hence, option C seems to be true. D of the above. If the both statement A, B, and C are true, then this option should also be true. Upon closer examinations, it is apparent that all statements are indeed accurate based on the given graph. Therefore, option D is correct choice. Thus, the correct answer is D, all of the above. Problem 8. A, B, and C are three vectors such that C equal A minus B. If a vector A had magnitude of 15 at a directional angle of 40 degree, and vector B has magnitude of 32 at direction angle of 130 degree. What are the magnitude and direction angle of vector C? A 30, 35.3 on 150 degree, 35.3, 35, 335 degree, 44.9 and 25 degree, 17.19 and 335 degree. Solution. To find the magnitude and direction angle of vector C, we first needed to understand vector subtraction. When you subtract vector B from vector A, C equal A minus B, you essentially added the opposite of vector B to vector A. Let's break down vector A and vector B. Vector A, magnitude 15, directional angle 40 degree. Vector B, magnitude 32, directional angle 130 degree. Now let's find the component of vector B to subtract from vector A. Component of B along the x-axis, 32 multiplied by cosine 130 equal minus 12.008. Component of B along the y-axis, 32 multiplied by sine 130 degree equal minus 27.08. Now, we can perform vector subtraction. C equal 15 multiplied by cosine 40 degree minus 12.08. 15 point sine 40 degree minus 27.08. Calculating. C equal 15 multiplied by cosine 40 degree plus 12.08. 5 multiplied by sine 40 plus 27.08. C equal 12.43, 21.45. Now, we find the magnitude and direction angle of vector C. Magnitude of C equals square root 12.43 raised to power 2 plus 21.45 raised to power 2 equal 24.2. Directional angle equal arctang 21.45 over 12.43 equal 62.8 degree. Now of the provided option match our calculated value exactly, so let's find the closest matched. The closest matched that to our calculated value is option C. C 46.9 and 25 degree. Therefore, the correct answer is C 46.9, 25 degree. 9. A particle moves in the XY plane and travels from the location 410 to the location minus 434 in 2 seconds. What are the magnitude and direction angle of particle average velocity? A 30, 50 degree, 53 degree, 30, 127 degree, 15, 53 degree, 15, 127 degree. Let us solve it. To find the magnitude and direction angle of the particle average velocity, we first need to find the displacement vector between the initial and final positions. The displacement vector can be found by subtracting the initial position vector from the final position vector. Initial position vector R I equal 410 and final position vector R F equal minus 1434. displacement vector R equal RF minus RI equal minus 14 minus 4, 34 minus 10 equal minus 18, 24. Now we can find the magnitude of displacement vector using the PHY theorem. R square root minus 18 square plus 24 square equal square root of 324 plus 576 equal the root 900 equal 30. To find the directional angle, we can use trigonometry function. The direction angle theta is given by theta equal arctan opposite adjacent equal arctan 24 over minus 18. Since the particle is in the second negative x and positive y, we need to add it 180 to the angle given by the arcing to get the correct directional angles. Theta equal arctan 24 over minus 10 plus 180 degree. Theta equal 127 degree. So the correct answer is B, 30 and 127 degree.
Solve the following two problems in the space provided in between, showing all your steps. Problem 1. A typical airplane needs to reach a speed of 306 km per hour before it can take off. If such a plane starts to move from rest, it spends 17 seconds on the runway. A. What is the relation of the airplane? How far does the airplane travel on the runway before takeoff? What is the speed of the airplane after traveling 250 meters? Let us solve each part of the problem. A. First, let's find the relation of the airplane using the formula. Acceleration equal change in velocity over time taken. Given initial velocity v equal 0 as the plane starts from rest. Final velocity equal 306 km per hour. Time t equal 17 seconds. We need to convert the final velocity from kilometer per hour to meter per second because the unit of time is in seconds. V equal 306 multiplied by 1000 over 3600 equal 85 meter per second. Now we can find the acceleration. Acceleration equal V final V naught over T equal 85 minus 0 of 17 equal 5 meter per second square. B. To find the distance traveled by the airplane before takeoff, we can use the equation. Distance equal Vt plus half At square. Given that initial velocity equals 0 meter per second. Acceleration equal A equal 5 meter per second square. Time t equal 17 seconds. Distance equal 0 multiplied by 17 plus half multiplied by 5 multiplied by 17 square. Distance equal 0 plus half multiplied by 5 multiplied by 289. Distance equal half multiplied by 5 multiplied by 289. Distance equal 5 multiplied by 289 over 2. Distance equal 1445 over 2. Distance equal 722.5 meter. Now see, to find the speed of the air after traveling 250 meter, we will use kinetic equation v square equal v square plus 2ad. Given initial velocity equal u, v equal o0, acceleration a equal 5 meter per second square, distance d equal 250 meters, v square equals z square plus 2 multiplied by 5 multiplied by 250, 500 multiplied by 5, then v square equal 2500. Then you can take the root for this, but between the two sides, you can see V equal 500 meters. So after traveling 250 meters, the speed of aeroplane. A projectile thrown from ground at angle theta above horizontal hit the ground again at the same level after 6 seconds at a location that is 168 meters away horizontally. What are the horizontal and vertical components of the projectile velocity when it was thrown? What is the launch angle theta? What is the maximum height reached by the projectile? To solve this problem, we can use the equation of motion for projectile motion. Here, how to solve it step by step. Horizontal and vertical component of initial velocity. Let's denote horizontal component of the initial velocity as v0x and the vector component of the initial velocity as v0y. We know that horizontal distance traveled by the projectile dx is 168 meters and the time of the flight t is 6 seconds. For horizontal motion, dx equal v0x dot t, 168 equal v0 dot 6, v0 equal 168 over 6 equal 28 meters per second. For vertical, dy equal v0 naught dot t plus half dot g dot t square. Since the projectile returns to the same level, dy equal 0. 0 equal v0 dot 6 plus half dot minus 9.8 multiplied by 6 square. v naught y equal minus y dot minus 8.8 dot 6 equal 29.4 meter per second. So the horizontal component of the initial velocity is 28 meters per second, and the vertical component of the initial velocity is 29.4 meters per second. B. Launch angle. We can find the launch angle theta using the formula. Theta equal r tang Vy over Vx. Theta equal r tang 29.4 over 28. Theta equal r tang 1.05. The theta is corresponding, that is 46.76 degree. So the launch angle approximately equals 46.76 degree. Maximum height reached. We can find the maximum height h using the formula. H equal v square over 2g. H equal 29.4 square over 29.2.8. H equal 29.4 over 19.6. H equal 864.36 over 9.6. H equal 44 meters, so the maximum height reached by the projectile approximately 44.1 meters.